Welcome back to the channel, folks. Wildlife Ranger on YouTube for all things natural history, and this series encouraging people to identify common British wildflowers. Today we're going to look at a little flower known as the Primrose Primula Vulgaris, which I am sure is a flower that everyone can identify with relative ease. So, before we embark to our trek to the field, we are going to focus on perhaps some things we do not know about this scented early flowering spring flower. The origins of the name Primula vulgaris comes from the Latin Prima, first or prime, and Vulgaris, common, the first common flower of spring. As always, before we embark to our trek to the field to find it, let's have a look at the relevant features and characteristics which enable us to recognise and identify it in the field. As follows, we will be explaining why the primrose has two distinct flower forms, the pin form and the thrum form, and we'll be explaining how this promotes cross fertilisation in a process known as dimorphism. The primrose is a scented member of the primrose family, the Primulaceae, growing 10 to 15 centimetres above the ground. It has pentagonal shaped pale yellow flowers circa 2.5 centimetres diameter, providing a flat landing disc for most insects. The pale yellow flowers have darker orange centres, guiding the insect towards the flower tube, which at its base contains a rich source of nectar, only available to insects with longer tongues or proboscis, such as certain bees and butterflies, such as the brimstone. The flower has 5 notched petals and it is dimorphic, meaning there are two distinct flower forms known as the pin and the thrum forms, and we will go on to explain the meaning of those two terms. The term pinnae is fairly self-explanatory, derived from the exposed disc of the sigma, giving a pin-like appearance. The term thummi is less obvious and has its origins in a weaving term known as thrum, the thrum being the frayed edges of a cloth resembling the protruding ragged edges of the stamen. Let's look at the leaves of the primrose, which are wrinkly with hairy undersides forming a rosette at the plant's base. From this tight rosette of crinkled rich green long leaves appear many flower stalks from the plant. As can be seen, these features are illustrated in the following clips. The primrose is a woodland and wayside plant growing on lawns, grassy banks and hedgerows with a preference to woodland, where it is known to be an indicator of ancient woodland. The phenology or flowering period of the plant occurs between January and May. The pollinators of this plant tend to be long-tongued bees or butterflies with long proboscises, which are able to reach the nectar at the base of the long flower tube. That includes also the early spring butterfly, the brimstone. There are possibly 3 confusion species: the cowslip, the oxlip and the bird's eye primrose. The following brief slide outlines some distinguishing features for each of the 3 confusion species, and the following image depicts a picture of the cowslip. As always with plants with confusion species, each species should be studied separately in order to make a competent differentiation. The following slide, which may be stopped at any time, contains further botanical details for anyone who wishes to study the plant in more detail. So that ends the identification part of the video. And for those who are interested, we're now going to go on to look at why the primrose has two different flower forms or morphs, the pinnide and the thromide form. In the up and coming clip, we illustrate in the field the difference between the thrum and the pin form, although I do apologise that the pinnide form is not immediately visible due to the limitations of handheld shooting. So, I hear the inquisitive ask, why does the primrose have two different types or morphs of flowers, the pin form and the thrum form? The short answer to that question is a process of dimorphism, which is a process which allows only cross fertilisation to occur in this species. So, before we outline form and function of the style, the position of the anthers in it, and the nature of the long-tongued insect using it, let's just look at some of the flower adaptations which make this strategy successful. So, let's just recap on the adaptive features that this little plant has. It has a broad flower disc upon which the pollinators may land. It is a colour yellow in the right section of the UV spectrum and a darker yellow in the centre, indicating in that spectrum that there is a flower tube. At the base of this flower tube there is the incentive to pollinate. nectar, which is only available to long-tongued insects or insects with long proboscis. In addition, the primrose is scented, possibly sending chemical signals to the insect pollinator. Before explaining the mechanism of pollen transfer on the long-tongued insect, let us have a look at the structural adaptation to form and function of the flower tube. The easiest way to appreciate this concept in the alternating slides is to focus on the orange anthers and the green disc of the stigma in relation to the relative positioning and form of the flower tube in both the pin and thrum flower. So in order to appreciate the next slide that follows, we just allow this animation to run through. In the next slide that follows, we will be looking at the actual flower itself, set side by side with the pin long form style versus the short form thrum style. In this actual flower image, compare the first and the third image with the second and fourth, i.e. the pin long style versus the thrum short style. Finally, the last piece in the jigsaw, which is the length of the insect tongue, in this case the proboscis of the brimstone butterfly or the long-tongued bees such as the bumblebee or honeybee. If an insect such as the brimstone visits a pinnide flower, it gets pollen stuck to the middle of its proboscis from the anthers which are halfway down the flower tube. If it then goes on to visit a thrumide flower, the pollen is ideally positioned to be wiped off on the stigma, in this case halfway down the flower tube. The opposite is also true. If the butterfly first visits a thrumide flower, pollen is wiped off onto the top of its proboscis as it searches and looks for nectar. This is then ideally placed to be transferred onto the stigma of the next pinnide flower to which it will visit. In this way, the strategy enables cross-pollination to occur in this plant. Cross-pollination as opposed to self-pollination is therefore very important in maintaining the genetic variability of the plant. Well folks, that's it from me. Thank you very much indeed for watching. If you have enjoyed this video, please help the channel become a success by liking, sharing or subscribing, and it will enable us to bring you the next video in the series. Until the next one, enjoy natural history.